Hey, my name's Avery. Sorry I look crazy, I just got back from dance. But in this video, we're going to be going over some more derivative problems and some different shortcut rules you can use when finding derivatives. So looking at this first problem here, our original function f of x is 3x minus 4 divided by 2x minus 8. And so in this case, we're going to use the quotient rule, which I haven't written out here, but it basically states if you have a function f of x, in order to find the derivative of it, you can find the derivative of the numerator and denominator individually and then combine them in such a way to find the derivative of your whole function. So in this case, your numerator can be h of x, denominator can be g. And this equation basically says h prime times original g of x minus original h of x times g prime all over g of x squared is going to give you the derivative of your whole function f. So in this case, like I said, the numerator, original h of x is 3x minus 4. H prime is just going to be 3. Mr. Moore went over finding derivatives, basically in another video, so I'm not going to go over that. And then our denominator, 2x minus 8, is our g of x, and then g prime is equal to 2. And then if you write out the work over here, that's why I wrote it separately, so that you can literally just plug it into your quotient rule. So h prime is 3, g of x is 2x minus 8, minus h of x, 3x minus 4, times g prime, which is 2, all over gx squared, so 2x minus 8 squared. And then you're just going to distribute those out and simplify what you have. So that gave me 6x minus 24 minus 6x minus 8 over 2x minus 8 squared. Your 6's cancel, and so f prime just turns into negative 16 over 2x minus 8 squared. For our second problem, our function f of x is 6x squared times 4x to the 5th minus 3x plus 2. And so in this case, we're going to use the product rule, which is really similar to the quotient rule, just a slightly different change in the formula. But same idea. If f of x is your entire function, you can find f prime by, combining h prime and g prime in a certain way, except in this case, your h and g isn't going to be a numerator and denominator. It's going to be whatever your separate functions are that you're multiplying. So in this case, h of x is this 6x squared, and then h prime is just 12x. And then your g of x is the second term, 4x to the 5th minus 3x plus 2. And g prime is equal to 20x to the 4th minus 3. Again, watch some of Mr. Moore's videos if you need help simplifying it. But this equation, you're going to do h prime times g of x plus h of x times g prime. And so, once again, just plugged it in to our equation. We got h prime, 12x, times g of x, 4x to the 5th, minus 3x plus 2, plus, this is where it's different from quotient, in one way at least, and then h of x, 6x squared, times g prime, 20x to the 4th minus 3. Once again, you're going to factor that out and, or distribute that out, and simplify. So once you multiply those two and those two, that gives you 48x to the 6th minus 36x squared plus 24x plus 120x to the 6th minus 18x squared. And so our f prime in this question is going to equal 168x to the 6th minus 54x squared plus 24x. And I just got those from combining like terms right here. So for our final question, we're going to be using a little bit of a newer topic, which is the chain rule. And the chain rule is used when you're looking at a composition of functions, or like a function within a function, it's also called. So in this case, our original full function, f of x, is 3x to the 5th plus 2x to the 3rd minus 7x to the 14th power. I wrote out the official chain rule here. I'm honestly not even sure how to read it out in these terms and it to make sense. So I'm just going to explain it like this. With the chain rule, you're looking at an inside function and then an outside function. So in this case, our inside function is this 3x to the 5th term right here. And then the outside function basically means anything, put to the 14th power, that's a function within itself. So in this case, we're just going to use u as a substitute at the moment. And basically what's going to end up happening is you're going to take the derivative of both the inside and the outside and then plug in your inside where that u is to get your derivative of your total function. So the derivative of our outside function, this u to the 14th, that's going to come to equal 14u to the 13th power. Again, that's just basic derivative simplification. And then our inside function, this whole 3x to the 5th term, that derivative is going to be 15x to the 4th plus 6x squared minus 7. And then all you're going to do is, remember that this inside function basically equals your u. And then so you're going to take the derivative or this outside derivative function and then plug in your inside derivative function where that u is. And in this case, you get your final answer, 14 times 15x to the 4th plus 16x squared minus 7 to the 13th. But in some other cases, there's going to be additional stuff out here. So you just got to be careful to simplify and combine all like terms that you can.